The Paladin is one of the easier problems in the set. It is a problem that we expected most teams to be able to get. The problem is, given a costs of pairs of letters, which we called runes, construct the least cost palindrome of a fixed length. Now there's an example of the total cost. You had to count every letter pair every time it appears, even if it overlaps with another letter pair. So for instance, ABACABA, you have to count AB, BA, AC, CA, AB, BA, and you see there the total would be 26. In this particular case, the least cost palindrome would be of cost 24 using ACACACA. So the solution is dynamic programming. You might have come up with an easier solution where you simply found the cheapest rune pair with its dual and repeated that over and over, but that will only work for odd length strings. Even length strings are special, and we'll talk about that in a minute. But with dynamic programming, let's let an array called cost, ij, be the cost of a pair of letters. So it's the cost of a rune pair where I and j are integers that index the letter. And we're going to use some code max. That's a variable that's defined to have a very large value, effectively infinity, if there is no such rune pair in the input. And best sub ij is the lowest cost for a string of length j that ends with the letter indexed by I. Now, this is a palindrome, and because it's a palindrome, we only need to work with half the length. So we're going to let K2 be half the length, and that's only as far as we're going to go. So let's go through that length, see what we can do, but the best we can do at each point. So if we've got a string of length I that ends with A, or I should say, if we have a string of length I minus 1 that ends with A, can we form a string of length I that ends with B? So the best we can do, B length I, is the minimum of what we've already got, plus if we went back one to that A and added B to the end. Now remember that since this is a palindrome, if we've got AB on the first half, we're going to have BA on the second half. So we need to add not only the cost of AB, but also the cost of BA. And that's how we would do things if the string were of odd length. But if the string is of even length, there's a special case that we've got to take care of. If the string is of even length, then it has to have the same letter repeated in the middle. Now, if we've gone through what we went through before, we've already handled AB, BC, CB, and BA, but we have to have this duplicated letter CC in the middle. So we've got to look for that, and that's why that simple solution won't work. You could have a very cheap AB and a very cheap BA, but if you don't have AA or BB in your rune set, you cannot use them in an even length palindrome. So the best we can get at the end, ending with I, if that rune pair is in our input, then we have to add the cost of that rune pair. And of course, we only do this for even length strings. So find the minimum full length ending with any letter. That's what we're doing here. We start with min equal to max. We just go through the end of that, the last column in that best array for every letter and figure out what the min is. And if we don't find one, we have to print -1. Otherwise, we print the min. And that is the solution to the Paladin.